All right, let's learn about modeling with quadratic functions. So we're going to start with a data set. This is the number of years since 1974, and this is the number of sales per year of Betamax video players. So when they first started, they had not sold any. After 1 year, they'd sold 4,400 in that first year. During the 5th year, they sold 20,000. During the 10th year, they sold 33,800. And looking at the data, we can see that this is an increasing function, but then it starts to decrease. So we suspect that it might be quadratic. Let's confirm it by plotting the points. All right, so when I graph the function, I can see that it is indeed quadratic because it has that nice parabola shape. So what we're going to do is find the parabola that best fits this data. I'm also going to show you how you can plot this data in Desmos, which is pretty easy. All right, so this is what it looks like in Desmos. There's really easy tutorials. They have a lot of videos to help you figure this out if you want to go that route. This is just an option. So you hit plus, you add a table, and then you just put your data, and it'll make a nice plot for you. Okay, but if you're just doing it by hand, you want to draw the parabola that best fits this data. So I took this very high-tech twist tie that I got from my coffee, and I'm just going to use it to help me draw a parabola. All right, so this is the very low-tech way of finding the best fit parabola. It's totally fine. And you remember that the general form of a parabola is this one. So going from my graph, I can estimate the vertex, which is H and K. So that appears to be at about X equals 20 and Y equals, let's call it 46,000. Then I want to find A, so I'm going to need another point on this graph that I can plug in and solve for A. All right, so I notice that I have this very nice point where the function goes through 0, 0. So I'm going to plug that into this equation and solve for A. So negative 20 squared is 400. Subtract 46,000 from both sides. And already you can see that A is going to be a negative number. That's what we were hoping because our parabola is facing down. So I get 115. So my mathematical model, negative 115 x minus 20 squared plus 46,000. All right, just using my rough graph, I can predict when people will stop buying Betamax units. So we can see that the rate is increasing. People are buying more and more until the 20th year. And since that's years since 1974, then that maximum sales rate would be in 1994. When will they stop being sold? Well, that would be 40 years later, or the year 2014. All right, let me show you how you can do this with your graphing calculator. All right, so if you hit the stat button, you'll get this menu, hit edit, and then you can enter your data in that menu and then graph it. You'll have to change the window to be an appropriate window for your particular data set. And then you can see it has that basic parabolic feature. Right, and if you want to use your graphing calculator to find your model, you can go to Stat, and it'll give you this menu, and you're going to hit Calc for Calculate, and choose number 5 for quadratic. All right, so it gives me this model. Now this is the same equation, only it's not in the factored form. Let me write that down for you. Right, so this is the model generated by the calculator. And then you'll want to check it by graphing this model against your stat plot. So you have your data. You're going to go into y equals, and you're going to type in your model. So you type in your model, and then you're going to hit graph. And it looks pretty good. And you can use that to predict when the sales will be 0. So you can just hit number 2, 0. It asks you for left bound. And a right bound. Oh, wait. All right, so let's go back. Let's find our 0. If you want to go to the left of the 0, we're going to be way over here. So I'm going to pick one where the y value is positive, hit enter, and keep going until the y value is negative, and hit enter, and then guess. I always just hit enter again. And it gives me 39.9, or approximately the same result we had for the other. So 20 is equal to 40. The number of sales will be 0. So again, we got 2014. All right, and as an added bonus, let's take a look at our function. This is a rate function. We can use the graph of a rate function to estimate the total sales. So let's draw a rectangle that encloses our function. So I have a rectangle here whose width is 40 years. And whose height is 46,000 units sold per year. So the height that encloses this, the height of the rectangle that encloses this function is 46,000 and the width is 40. We can calculate the area of this rectangle, which is going to be 46,000 times 40. So the area of this entire rectangle is 1,840,000. But what we're looking for is the total sales, and that's going to be the area under the curve. And you can just kind of guess what percent of this rectangle is in the shaded region. And I'm going to call that about 70%. So the total sales is going to be 70% of 1,840,000. And that's going to be approximately so we just take 70% of 1,840,000. We get 1,288,000. And that approximates the total number of Betamax units that were sold in this 40-year period. So let's look at the units here. We multiplied 46,000 Betamax units per year times 40 years. So the years cancel and we got Betamax units. All right, what are some of the things that we can use this model for? We can use the model to predict the maximum or y-intercept, or you can even calculate the average rate of change between any 2 points. So if you were producing Betamax units, you could say how fast are the sales slowing down? So that's something you could calculate using a mathematical model. All right, and then going back to Desmos, you can superimpose your model on your data points so that you can make your predictions. And you can also draw in a horizontal line if you want to draw the graph of your rectangle. All right, that's it.